I am very, very happy to welcome you to the second part of this question 2 of our 2026 chemistry practical alternative A. So I urge you to watch this video to the end. This is going to be very, very simple and it's not going to take us much time. They are going to give us a white substance and they will ask us to carry out these exercises. Remember, you must have watched the first video to understand what I'm doing here. So this is the second part I am suspecting that they're supposed to give us, and this is coming from my colleague. My colleague told me that why not we also think of adding HNO3 to the sample since all of them are insoluble. So let's go with the idea. And if they ask us to add HNO3 first, we are going to notice that a part of the substance will react, some will remain. So while it is reacting, it's going to give us effervescent effervescent of a colorless, odorless gas. And if you bring down litmus paper, both the red and blue, closer to it, is going to turn the blue to red. Just as I said in the previous video, since it turns to red, what we are going to do here is to claim that the gas, being acidic, can turn lime water mucus. So look at our inferences, look at my observation, look at my inferences, look at all my inferences are coming under my observation. You should be careful on that. Mind you, my C is C solid. I make sure that you know that it is solid I am dealing with. Did you get me on that? Okay. It is also possible for them to ask you to use filtration to separate the resulting solution from the insoluble substance, insoluble white substance. If that is being asked of us, what we do is we just need to use our filter paper and separate that. And if the HNO3 is actually very concentrated, the substance would have turned down, but thank God we use dilute. So look at the inferences. For the filtrate now, what we need to do is add sodium hydroxide in drop and in excess. The observation in drop is going to give us white chalky precipitation, but in excess is going to be soluble. And in that white chalky precipitation, the substance or the ion we are expecting is calcium and lead 2 plus. That is calcium 2 plus and lead 2 plus. To my student, I call it carb. So that is what we use to know chalky precipitation of white. You get that? Okay. Now, because it is soluble, we know that lead is an amphoteric substance, so it is going to be soluble in excess of sodium hydroxide because it's going to react with it, just as you can see in this reaction. Okay, so what happened here? We're going to tell them that lead is present since it is soluble in excess. They can still ask us to add ammonia hydroxide, or they can ask us to add aqueous ammonia or ammonium hydroxide to it. So if they ask us to add it in drop and in excess, what will happen is going to give us again white chalky precipitation, but it is not going to be soluble in essence. So my inferences is Pb2 plus present, and my inference is still the same Pb2 plus that is present. I have a reason why I give them differently. It is possible for you to just to give it once, but I prefer you to give them separately so that you understand this. Now the residue is what remains. In the residue, what we have in the residue, we are going to use something like what I suspected is it's possible for them to ask us to use heating for the residue. That is, we will divide the residue into two. If you heat it, we are going to have a black substance, meaning that carbohydrate is present. But if they ask us direct to use iodine solution, we are going to see it turns blue-black. That tells us it's starch that is present there. With your thinking and with your mind, I believe you have seen the possible substance that are there. What about the part C of this? In our next lesson, I'm going to show you the possible C pattern of the question they might ask us. Be there.